Turn this on. If you look at 22, they're trying to show you how to set one up. They say R, no, I can't read, S goes to 45 the way that 28 goes to 42. They're matching up things that go together. Let's kind of trace and see what they did here. Your S is this side right here, and they're matching it up on the bottom of the fraction with the side that over here on the similar triangle. These are similar triangles, so they're saying the side S and the side 45 match up, so they're going to make a proportion out of those. So if you notice, they're putting the, I guess we'll say the small one, dimensions on top, and they're putting the larger fraction, I'll just put big, on the bottom. So now they want to find S. So if you make a proportion with the variable in it, you need to make another proportion that has sides that match up, that actually have numbers on them, so you can cross multiply and solve. So if you notice what they did, they said, okay, 28 on the small figure matches up with 42 on the large figure. So then you can find the side S by cross multiplying. So you'd have, if you do that, you'd have 42 times S is 42S, and then 28 times 45, you really want to have your calculator, or you're going to be doing a lot of gross multiplication. Okay, so if I want to solve for S, what am I going to do?
Divide.
Yeah, divide by 42. And we get 30. S is 30.
Somebody wrote the answer in the book. I see it. Thank them, they're your friends, I promise.
So S is 30. Let's go up here and label it. We're going to need some of these numbers and some of the problems that come after this. So that's how you normally set these up. This was 22. That's how you normally set these up, is you just match. You find, if you're trying to find the variable, you match the variable up with the side. It's matching side in the other figure. You make one proportion out of that, and then you find another pair of sides that actually have numbers on both of them. If I wanted to know what the scale factor is, you know what I could do here? You see 28 over 42 over here? I could divide 42 by 28, and it's 1.5. If you think about it, if I multiply 28 by 1.5, that's the scale factor that would help me find all of these sides over here. So I can figure out the scale factor if I want to. As a matter of fact, the reason I wanted to point that out is we're going to need it in 25 and 26. So just remember, the scale factor for this triangle is 1.5. Let's just check it out. What's 26 times 1.5? It better be 39, and it is if you're following along in your calculator. And if we want to see if we got that S right, we could say 30 times 1.5, and we get 45. So our scale factor here, it's like doing the dilation and finding the scale factor. It was 1.5. Okay, so on 23, they're just having you cross multiply and solve for the height. And you know what? We're going to need that number, so why don't we just do that together? If this is a similar triangle, then even the heights are similar. So let's say I want to find the height H. They actually built that one for us too. They started with the bigger triangle and put the numbers over the smaller triangle, so they're kind of doing big over small here. Sometimes it helps to write what you're doing over here to the side so that you don't accidentally put the numbers on the wrong side of the fraction, because that'll get you the wrong answer. So what they did is they said H matches up with 24. And then they took the pair of known sides, 39 and 26. 39 on the big triangle. Man, it's not taken. 39 corresponds to 26 on the other side of that similar triangle. So now we can cross multiply and solve. So if you got your calculator, why don't you do that real quickly? See if we all get the same answer. You remember back in junior high, did your teachers teach you this? You multiply the two numbers that you know and you divide by the number across from the variable. Did y'all learn that? No. You can solve it like we're doing here.
I don't really remember anything from Mr. Burt. Same. Neither do I. It's okay. Oh, that's right. You had him too. That's why I retook Algebra 1 in 9th grade.
Oh.
Which was a good idea. I probably should have taken Algebra 2 this year. But
Divide both sides by 26, right? And what do you get? 36, okay. So our height over here is 36. Let me fill that in. because we're going to need that for 25 and 26. So you're still working off all these figures all the way down through 26. 24 is just confusing. What do you think it means for you to do?
Just reduce each one and see if their base ones match.
You can do that. You could reduce each fraction and see if the decimal's the same on both sides, or you could cross multiply and see if they cross multiply to the same thing. You can do it either way. Okay. So I'll let y'all do that on your own. But let's look at 25. What I'm going to do. Okay. So if I redraw those quickly, and I fill in the numbers, this why don't I just draw and we'll fill in the parts that we need. We had over here, what did we find out that S was? I don't remember. 30? Okay, thank you. And then this was 28. And then over here we had 39. They actually gave us all these sides. Okay, so if you look at 25, here's one thing they're wanting you to notice. And by the way, we're going to take more notes on this at the end of the week. It's called dimensional change. This is the idea behind what they're getting at here. So let me just show you what happens. Do you remember that the scale factor earlier we said it was 1.5? Let's just kind of keep that in mind, okay? That was from one side to the side on the new triangle, what they would multiply by. On 25, they ask you to make a fraction out of the perimeter of DEF, and this was DEF is over here. And this was A, B, C. Y'all see why I never use the erase now. So for the perimeter of triangle DEF over the perimeter, I'll just put PER, triangle ABC. So how do you find the perimeter?
Add the sides.
Add the sides, okay. So let's see. Dream on. Okay, so 45 plus 39 plus 42, we get 126 on top. And then add up for ABC, add those up also. Some of them did. 84. Did y'all get the same numbers I did? Now divide it out and let's see what that divides out to. 1.5. So when your sides are proportional, your perimeter will be also. The reason that is what are our units going to be on this? Did they tell us? They didn't tell us, did they? Let's say in perimeter, it isn't like taking a tape measure or measuring around something. I could actually do that with a ruler or a tape measure, right? It's not any kind of unit squared. It's like I could measure that in inches, for instance. But let's think about area. Is area, for instance, inches? When you hear area, what kind of units do you usually get with that? Square units, right? Okay, so let's look at what happens with area, and let's kind of notice something. If I want to,
I have a question on 25 real quick. So I just, I found the perimeters for...
You have any predictions? Well, we just do it and we'll see what happens then, okay? So...
Can you really do a pin drop?
No, I'm not going to say anything.
Really?
All right, so if I want to find the area, it is base times height. So let's do DEF is the big one. What's the base on DEF? 42. And what's the height on it? You should probably have it written on your 36. We found that earlier, right? Okay. So let's just multiply that out. 1/2 is 0.5, right?
No. No.
42.
Almost causing conflict. I'm so sorry.
Okay, so it's 756. Okay, on top I got 756. Let's find the area of ABC. It's 1/2. Its base is 28, right? And didn't we find its height a while ago? Oh, it's 24. It's on there, isn't it? Okay. So let's multiply that out. And I get 336. Now let's divide that out. Let's divide 756 by 336 and see what happens. Do you think we're going to get 1.5?
No.
We get 2.25. Do you remember any relationship? It's at square, and then if you square 1.5, you get 2.25. So the area is the same thing as the scale. If you make proportions, if you make a fraction or a proportion out of the, I'm sorry, not a proportion, a ratio is just one fraction. If you make a ratio out of the areas, it will be the same thing as whatever the scale factor was squared. So we don't get 1.5 here, we get 1.5 squared, and that's because the units on area are square, square inches or square whatever. So you don't get the relationship. Most people think it's going to be the same, but it ends up being this number squared just because it's affecting each dimension, so it gets kind of factored in there twice. And we're going to be taking some notes on this at the end of the week.